Good afternoon, everybody. Greetings from Barcelona. My name is Elham, and my colleague Francesca and I are going to present you RhinoLands. So let's start. Well, RhinoLands actually is the bundle of lands design as a plugin, landscape design plugin with Rhino in a standalone form. So what you will see in this new version will be a simplified interface of Rhino on top, as you see, with all its necessary tools for designing a landscape project. So the solution is a standalone with simplified interface and with perpetual or permanent licenses. The program helps us to have 2D drawing, technical drawings, the 3D model. It automatically generates a list of plants and other materials, and there are some tools for visualization and animation of the project. So the program is used basically in the field of landscape architecture, but during infrastructure design used by civil engineers, in urban planning projects, and in environmental projects. For example, we can easily model a forest by using the tools of this program. Let's take a look at its main features. First of all, the program includes an extensive plant database with more than 8,000 plant species. The plant database includes several filters to help us to select the adequate plant based on plant type, flowering, soil type, climate, and so on. So the plant database also includes botanical information of plant species. If you click on the properties of each plant species, you will find more information. And also it includes several blocks of the same plant species that are going to be used in different displays of the program automatically. So this is a display mode of conceptual. By one click, you get the detailed. By another click, you get the realistic one. And the realistic representation has the feature to show us the project in different seasons. So by moving the slider, you will see that how would be this landscape in different seasons. So in this way, we can have a better knowledge and better understanding of how would be the scene during the year. Then there is a useful tool to help us to shift between 2D and 3D by one click. So for those that are used to work in 2D environment, they can continue working in 2D environment actually. And then by one click, they will see that, well, the 2D blocks actually are linked with a realistic 3D plant models. We have different ways to insert plants. One is inserting them individually. Another is inserting them in a row, or by paint, as you see by moving the mouse on the plot. We can convert points to plants, and we can convert blocks, any kind of blocks. For example, AutoCAD blocks, we can convert them to realistic 3D plants of land design, indicating the name of the species. We can insert a row of plants or a group of plants by indicating the distance or the minimum distance or the order of the plants. Also, we can insert shrubs by indicating the number of units per square meter or per linear meter, or insert ground covers in the same way. Inside of plant database, we have a plant editor that helps us to edit an existing plant and save it as a new plant species, for example. In the case that you miss any plant species, you can easily copy and modify an existing one which is similar with your plant. We have powerful terrain modeling tools that help us to generate a terrain based on points, lines, or combination of points and lines. Once the terrain is generated, you can easily modify that by using control points and by using earth-moving operation tools like cut and fields, create a path, and so on. The program automatically calculates the area and volume of earth-moving operation of each operation. You can also divide the terrain in different parts and assign different texture and material to each part of the terrain. So in this way, we can have a calculation of two alternatives, for example, for the same project. So we are going to have a road on this terrain to connect the top building with the rest of neighborhood. So we can compare the result of the earth moving calculation that program provides us automatically. And by comparing these two alternatives, we can decide better about the development project. There's a nice tool for converting DEM file or digital elevation models to a 3D terrain. So if we have DEM file or like TXT file formats, we can import them, open them directly with Lands Design in Rhino, and create the terrain in this way. So everything does automatically. When we have the terrain, we can obtain also the contour lines of the terrain. In addition, we can import terrain from the web. In the case that we are working on an area that we have no topographic information, by indicating the location of the project anywhere in the world, if we indicate that on the map, the program automatically generates the 3D terrain of that selected area. The program uses a global elevation database for that issue. And well, the precision in this way is one sample each 10 meters. So as you see, we can import the 3D mesh, including the satellite image, and we can import the terrain that help us to have the topographic contours as well. Another feature is that we can import 3D buildings. In this example, we are going to import the Central Park of New York. So you will see that there's a nice way to have a rapid site production. We import the terrain and all its surrounding buildings. It is not so precise, but it helps us to have a kind of background for our project. We have dynamic documentation tools that help us to insert the list of plants, zones, furniture, earth moving operation, and so on. We have some tools for adding the image of plants, and other tools for creating labels and producing different types of plants and sections, as you see here. For hardscape, we have parametric tools to create walls and curves, parametric walls and curves, so you indicate the height and thickness of the wall, parametric paths, parametric stair, and parametric fences even. So you decide about all the details of the fence, and then you are going to use that tool. Also, there is a block library of the furniture inside the program, but you can add your own blocks as well. So we have irrigation tools, as you see. There are just simple drawing tools. They are not 3D, but it helps us to have the irrigation plan of the project. The program automatically generates a list of sprinklers and pipes. For visualization tools, we have several features. There is walk mode, so we can walk through the project. We have virtual simulation, so we can see how would be the growth of project, for example. We have sun and shadow tools, so we can see that how, let's see in this video, how the sun and shadow will move during the daylight, the daytime, and during different seasons of the year. So as you see, by moving the slider, you will see how would be the shadow movement in your project. So this feature helps us to select the best place for sitting area and dividing the site in different parts. Also, there are some tools, some render possibilities. The program is fully compatible with the most important render engines in the market. And there are some image editors. So this is the rendering with Rhino. So in the case that we are not going to use any external render engine, we can also obtain a realistic rendering by using the internal Rhino render. But in the case that we are going to use another rendering engines, these are the examples. They're using Enscape, Twinmotion, V-Ray, and Lumion. All are compatible with the program. So the animation that you will see here is made by from a model that is made in RhinoLands, and then the animation is made by using Enscape. So the plants that you will see here are real plants with a name, with the botanical information. They are not like render assets. There are native plants in RhinoLands. So we have also the parametric design with Grasshopper as a feature in our program. So the parametric design helps us to use algorithms to create geometry, like the geometry that you see in this image, or we use the parametric design tool in our case Grasshopper to link data to a beam geometry and then do different types of analysis. We will see that later. So these are Grasshopper components of the program. Plants, shrubs, everything can be linked to the algorithms for generating or for linking different objects together. This is just a simple example that we are going to see here. We are going to have first inserting some plants with different size in the program. And then by using Grasshopper, we are going to have some plant pots with the same diameter of the plant. Since the plants have different sizes, the pots also have different size. And by moving the plants, pots also are moving automatically because they are linked to the plants. So this is a simple example, but you can imagine that how other possibilities can be done by using Grasshopper. It is an advanced level, of course, so you don't need to learn that in order to be able to work with the RhinoLands, but it's an advance and a plus, a big plus for those that are going to work more professional. So by using Grasshopper, we can do environmental analysis. How we do that? We link environmental data through Grasshopper to our model in RhinoLands. Then we do different types of analysis. Some examples of them that are available right now are as you see here. So we have CO2 calculation by modeling a park in RhinoLands. We will know that how much CO2 or how much carbon will get sequestrated. How would be the cooling effect of plants on the floor? How would be the shadow analysis and the shadow, I mean, the percentage of the floor that is covered by plants in different hours and different periods of the year, for example. And also we can do solar radiation. We can calculate solar radiation. So we know how much solar radiation will get absorbed by our plants. In this video, you will see that in the CO2 calculation. So this is the definition that we already developed. So our users can download that and then link that with their 3D model. So if they design a landscape using the program, they will have access to this calculator, and then they can calculate how much carbon will get sequestrated by implementing this park, for example. Another feature is that connection to Revit. For those that are collaborating with architects and they are using Revit, this connection is quite useful because what we are going to have here is that when you have a project modeled in RhinoLands, by adding some definitions into Revit that we already we already published them. So the users will copy those definitions and place them in a script place in Revit. And then, well, as you see here, they copy them and just they place them there. And then they can open their landscape inside Revit. And all beam features of the program will keep. So by one click, they import the terrain. Click on terrain definition, they import the terrain. By clicking on another one, they give zones and so on. So as you see, when the terrain is imported into Revit, Revit can recognize that this is a terrain. These are different parts of this terrain, the different subdivisions, and so everything is readable as a beam object in Revit. So in the similar way, we import by clicking on different buttons, we import different parts of the project, different types of different categories of our objects. And when we modify anything in Rhino, you will see that everything moves automatically, updates automatically in Revit as well. So for example, we are moving these fences and these plants in Rhino. And then when we have the project there opened in Revit, by clicking again on their definitions, you will see that they will update automatically. So this is the design process basically by using RhinoLands. You can import the terrain from the web, or if we have some topographic contours, as you see here, we can elevate these contours, and once they are elevated, we can generate the terrain. Okay, so once the terrain is generated, we can do different types of earth moving operation on top of that. We can zonify the project in continuous. So we indicate different polylines, closed curve, and divide this project to different zones. We indicate the label of zone material. In continue, we can add plants and vegetations in different ways, as you see. So, for example, we are going to insert a row of plants, but we indicate the distance. We can have a row combined of different plant species and so on. Also, we can insert a group of plants in the forest and so on. So we can continue to hardscape, insert walls and curbs, insert paths or stairs if we have, and also add some furniture to the project. In this simple example, we don't have hardscape, but there are hardscape tools. So at any moment of the design process, we can shift between 2D and 3D. So if we are more familiar in 2D environment, we can modify our objects in 2D environment. For example, we are going to move this forest. And then when we switch to 3D, we will see that everything is changed automatically. Then we get the list of plants, zones, irrigation, furniture, and so on. So we get different lists automatically. And finally, we can render the project by using the render. So this is the workflow. Basically, you can do everything by using RhinoLands. I mean, drawing, 3D, and even rendering. But in the case that you have some AutoCAD or any kind of CAD file, CAD drawings, you can import them into RhinoLands. For example, if you have DWG files or SketchUp files, you can open them directly in Rhino. If you have geographic information and geographic files like GIS, DEM files, or point clouds, or LiDAR, we can open them also directly into RhinoLands. For visualization, we can use different render engines that are compatible. We can use virtual reality headsets to visit the project in virtual reality. We can use a 3D printer to print the project. We may print our documentation, so we get the list of data, and we can export lists to Excel, for example, and so on. And for collaboration, we may have collaboration with other BIM programs, like, as I mentioned, like Revit, also like ArchiCAD. We have IFC export and import support, so we can import or export other BIM blocks and projects into the program. So we can do the whole project by using RhinoLands. It means different types of plans and concepts, conceptual plans, different types of sections, and finally the realistic rendering of the project. This is a real-world application of the program. There is a master project in Madrid, and everything is used by applying Rhino and Lands design at the moment. So it's used by RhinoLands. Well, so in summary, we have 90-day free trial. The licenses are permanent. You will have technical support from our team, and there are educational and lab licenses for schools at a very reduced price. This is the project, the image of our project gallery. So later on, you can take a look at our project gallery to see which kind and which type of projects are done using the program. And up to now, do you have any questions? Okay. So I'm going to ask my colleague, Francis, to share his screen.
Thank you. Thank you very much, Elham. So I'm gonna share the screen. Go. So basically, we'll see well, a quick live demo of what we have seen in the presentation. So this is the interface of RhinoLands. So again, this is a simplified interface of Rhino with land design integrated, right? So we know that Rhino is a very powerful tool. It has hundreds of tools and features, but we have simplified and the interface with only those tools that we consider important for carrying out a landscape or architectural project. Okay, but the tools are there. Okay, if you search for any command existing in Rhino in the command line, you will find it easily. Okay, and also you can run Rhino and with land design loaded, and you can work with land design on Rhino as another plugin. Okay, I would like to ask you if you can maybe type in the chat if you already know Rhino or you are familiar with it or not. So it will be interesting to know if you are already familiar with it and you have a well, an idea of its capabilities. Okay, so if you are so kind to just let us know, will be great. But in any case, if you're not familiar with it, so we can find here, well, a typical viewport. Okay, we have a perspective viewport, a top viewport, and some front and right. Okay, we can expand a viewport by doing double click. Okay, or just minimize the view back to the 4 viewports. And we can find here all the necessary tools to draw in 2D or draw with 3D objects. Okay, this is just pure geometry, like let's say geometry without any parametric features. But if we check the other commands, we can find some objects that are parametric, they are smart, and we will be able to edit them through parameters very easily. Okay, for example, we can find here all the vegetation commands, okay, or objects to insert plants that can be inserted individually from paint mode, from blocks or points, arranged in row or in forest. Some other ways to insert plants through shrubs or ground covers. We can find here some commands to insert hardscape objects, okay. And if we go on, we can find some irrigation tools, some documentation tools to make reports of all the objects that we have in the scene. So we'll be able to list all the plants, also urban furniture. We will be able to create the zones list or calculate the movement of land volume, okay, when we do operations on terrains. So we'll see some examples of this listing, okay. And in addition, you can find here all the dimensioning tools, okay. If you are familiar with AutoCAD, for example, RhinoLands also have, you know, the page layout, so we can prepare here the all the sheets for presenting the project. Okay, so it's the same idea. Okay, this is like a viewport, a window to the model space. Okay, so you can work from the model space and see everything in the page layout. And finally, we have some other visualization commands, you know, to change the viewport position, change the display mode in each view, or shot renders. All right. Also, from the right hand, we can find here properties panel. Basically, anything that we draw here, let's say that we want to draw a box, right? We'll be able to select it and check the properties from the right side of this dialog. Okay, we can find here also properties such as the name, layer, where it goes. So basically, we can also work with layers when we are in RhinoLands, similar to other programs like AutoCAD that you might be familiar with. And through these panels, we can well, play with the sun. Well, there are many options, okay, that we can explore. Maybe another important point here is that imagine that you start with a DWG file. Okay, so that's what you get from the architects or from the collaborators, or because you started the project in AutoCAD and you developed everything in DWG. So we may need to import that DWG file into RhinoLands. So first thing that we can do is to open or import this document. Okay, so I'm gonna select just a regular DWG file. Okay, and we will see. Well, this is the import options, basically how you want to import all the curves and other elements, and we'll get a pure, DWG file with all these curves that we'll be able to change the control points and so on. Okay, if we check the layers, we'll see also the layers that have been imported within this DWG file. So on top of this 2D drawing, we can start modeling the project, creating 3D geometry from these curves, creating terrains, and so on. Okay, so I'm gonna switch to the same project, but a little bit more developed, right? So you can see here we've got the same guidelines, okay, that came from that DWG file. And well, the first thing that we can explore here is the different display modes that Land Design provides for the, especially for the plans, but actually for everything that we insert in the model. So we can switch from this realistic display mode of plants. Here we can see the plants with very fine detail, with all the textures and materials, on the leaves. Although this actually is a simplified representation of the plants, because when we shutter render, these objects are replaced by a better blocks with a higher level of detail. Okay, so even though they look quite nice already, when it comes to shutter render of the scene, we'll get even a better result. Well, the vegetation elements have different display modes. For example, we can switch from to realistic to these elevations. Okay, so when we are in the right viewport, we may want to see them in this elevation mode. Conceptual, if we just want to have, a conceptual representation of the plants, because we are working on a new urban plan, okay, in a city scale, and we just want to see, the shapes of the plant. We've got this other detailed more mode, okay, and finally the realistic, which is maybe the nicest, and the one that also can handle different appearances according to the season. So basically, when we should render, we'll be able to tell the model if it's rendered in one specific season or another, okay, from this dialog over here. Also, there are some other settings to control the quality of the render, but well, depending on this season and the plant species, they will look in one way or another. Okay. Now, let's actually these different representation modes can be different from every display. So actually, if we go to the viewport and we select the detailed representation, this affects to all views. But we can decide to do not synchronize this. And for example, from the perspective viewport, we want to see everything realistic. And maybe from the top viewport, we want to see everything in 2D. So here is where we can activate the plan view representation, where all the zones will be displayed with the hatch pattern. All the plants will be displayed with a 2D crown. Okay, actually, we have the option also to switch to a setting out symbol here. So we can have different representation in each viewport. Well, according to how we want to work. For example, if you want to work in 2D, maybe it's more convenient to show the 2D representation, or if we're in in the perspective viewport, maybe we want to see everything in perspective. Okay. All right. Also, to handle a large amount of plants, there is the option to show a billboard representation of these plants. So basically, we'll get just surfaces with texture, and this way we'll be able to work in rendered display mode with a large number of plants and still have a good experience in terms of performance. Okay. In any case, since this is a small project, I'm gonna switch to 3D representation. Okay. Right. Let's move to the top viewport. Before going through some of the vegetation commands, let's insert a zone here, because this is usually one of the first steps in the design process to have an idea about the areas in the project. And here we can see that we've got some curves. Okay, so we have a boundary curve, and we have an empty area, and we want to calculate the area on this rectangle, right? So I'm gonna run the zonify command for that. So I can select this boundaries option, and now I will select that rectangle. And well, zones are defined as a hatch pattern in 2D and as a textured material in 3D. Okay, so you can browse here from the library of materials to find another texture. Okay, and in 2D we can also select any 2D representation, a hatch pattern, color, and so on. We define a label name, okay, some other parameters, and finally we just need to click to insert the label. All right. If we switch now to 3D, we'll see the hatch pattern. Well, as long as I'm using the rendered, of course, in this mode, on that zone. Okay. So back to 2D. I'm going to now insert the zone list, since we have created the zone. And when I insert this listing here, we will see this building with the corresponding area. And this is a list that is connected to the 3D model. Okay. For example, we can select it, we can check its properties, go here to zoning list, and maybe add a simple icon. Or if we edit this zone, for example, we change the name of it, building 2, for example, we'll see all the changes updating into this list. Okay. Now let's move to the perspective view, and maybe let's insert plant. Okay, and we'll see how this works. So we close to this area and go to vegetation and insert a plant. So in this case, the insert plant dialog appears. Here we can see the existing plant species that I have already inserted in this project. But in an empty document, you would have this list empty for sure. And then you will need to browse into the plant database to search for one specific species. Okay. Well, this is the plant database. Here's where we can start, searching for specific species according to all these characteristics. Just notice that here from the header of the dialog, we can see how many species match the criteria that we are specifying here. So if we start, selecting all these filters by leaf type, plant type, so on, we'll see the number of coincidences. Okay, and from this dialog, we will be able to explore the different species that we've got. Okay, with the corresponding images and representation modes. Okay, we can clear this search and also try to find a species by its scientific or common name. Also, we can find here some groups of plant species. For example, not all the plant species come with a specific realistic block, okay, for its appearance. So we can filter those species that come with, one specific plant for the 3D representation that, well, they have been designed especially with a plant editor that, well, for that species. Okay, but most of them, if they don't have a specific, realistic plant in 3D, they take the most similar one. Okay, according to the family or the plant species. Okay, now we can also find here a specific plant. For example, let's look for a lemon tree. Okay, so I can find here a citrus lemon. By the way, we can create new plant species. If you don't find the desired one, you can duplicate one and edit the copy, or you can create a new plant from scratch from this button, and just you'll get this technical sheet where you need to fill all the parameters. Okay, not only for information, morphology, or characteristics, but also the how we want to represent this plant species in 2D or in 3D. Okay, so we have a library of 2D crowns that we can explore. And this is nothing but well, a collection of 2D blocks that stored in a specific folder, and you can actually add your own 2D ground if you don't like any of those available. So you can add it in that folder. And well, here you can also assign one of these realistic plans. So there are over 600 or 700 files for this representation. Okay, so I'm sure you will find maybe a good one. And these are files that, again, they can be edited, that they can be created from scratch using a plant editor that is available as a separate plugin, but it's free, and it's actually one of them is integrated into the program, so we can launch it from here. But depending on the file format of this plant species, you may need to install the other plugin. But anyway, I'm going to select that citrus lemon. Okay, we define here the size of the plant. Also, we have this natural variation check, and we insert several units of this plant species. All of them will be a bit different from one to another, okay, in terms of height or also in terms of rotation. So even though they are the same block, they share the same block definition, every plant will look different from one to another. So we insert maybe a few units of this lemon tree. Okay. All right. And once we are done, we can select this plant. Okay. And from the edit panel, we can change the species into any other one. We can change the size of it. Okay. So there are all the parameters available at any time after having inserted these objects. All right. So before we see some more commands regarding vegetation, let's work on the terrain, okay? Because this is also one of the most important features of RhinoLands. And we go to the terrain tools, and well, again, we can create a terrain imported from a DEM file, or we can import from the web, as we have seen in that presentation, or from a GIS data. Okay, there are commands to import data that we'll be able to use for creating terrains. But imagine the situation where we have some 2D curves, okay, because you get it from the topography data or from a DWG file, and you get all the contour curves of the terrain on the same elevation. Okay, so the first thing to do when creating terrains from curves or points is to position these curves in the corresponding level or elevation. Okay, and they are, in this case, they are all flat. So we have this command, elevate curves, that will let us elevate these curves according to an increment. So we draw a line, and now all the curves that intersect with this line will be elevated according to that interval. Okay, when we click apply, we see that the curves have been elevated. Okay, now we can run the terrain command. So we select the curves. Just notice that when running any command, we just need to follow the instructions in the command line. Okay, so it's very easy, very user intuitive to to explore all the commands, because you just need to follow the instructions below. So we can also include points. Okay, so it can be a combination of points and curves. And when we hit enter, we specify the properties of this terrain. So basically, terrain is kind of a mesh, a gridded mesh. So we can define the cell size, okay, and whether it has a base or not. Also here, we can define the contour lines. So every 1 meter, every 50 centimeters, every maybe 20 centimeters, okay. So we can define all these options here, and also assign a material. We'll click OK. And we get the terrain, on top of these curves, which, by the way, we can already delete or hide, because we don't need any more to create the terrain. Actually, we had those lines in specific layer. I'm gonna hide these lines now. topography. And if we select the terrain, we can appreciate that all these, well, the control points of the curves, the regional curves we use it to create the terrain, have been absorbed by the terrain. So we can select these curves and just pull them up. So the terrain will be modified according to this change. We can use this control arrow to move the whole curve above and get, well, modify the terrain this way, okay? And we can show the terrain also in 2D and 3D simultaneously. So this is an option available for terrains that actually is quite useful to, to see a better feedback of how the topography works. We can maybe hide the base. And now, well, we have part of the terrain that is maybe occupying, all this park, and we don't want that. We like to trim this terrain. And I've got here a boundary curve, okay, which is this one. And actually the selection, maybe I will work in wireframe. Yeah. So, well, I'm gonna trim the terrain by this boundary curve. Okay, so there is a command here, which is set boundary. And again, we need to select the terrain, select the boundary, and the terrain will be trimmed by this curve. Okay. All right. By the way, just notice that as soon as we create the terrain, all the objects that were on top of it are projected on top of the terrain. Okay, that means that if we, for example, make a copy of this plant, I go to copy command and insert a few units around here. Basically, the plant will detect the position of the terrain and will be projected on top of it. Okay, so you don't need to move it manually, because the plant will identify the position of the terrain and will be, projected on top of it. Okay, let's see some more options here. For example, terrains can get some operations, and then from those operations we can calculate the volume of earth movement, okay, the land movement. For example, we can add a cotton fill here based on a curve. So actually, you've got here some lines. No, not here. Maybe it's here. Well, doesn't matter. I'm gonna create it. So I'm gonna draw a rectangle. Maybe I will work from the top viewport, so I can better figure out the position of this curve. And let's imagine that we want to flatten that area around here. Okay, so now we've got this curve on the zero elevation, but we can move it maybe a bit upwards, in a way that part of the curve is inside the terrain, okay, and the other is just outside. And that's the area that we want to flatten. So we go to terrain tools, we select this cut and fill command. Again, we follow the instructions in the command line. So I pick terrain, I define an angle around this curve. So basically how the terrain will meet, the boundary curve. And finally, I select that closed curve. I need to define if I want to divide the region or not. If I say yes, I will be able to assign a different material to it. Okay. There we go. So we can see now that we've got some volume of land that has been added and other that has been cut. Okay. And from the top viewport, maybe now we can quantify this volume of earth movement. Okay, we've got under the documentation tools this command to do terrain list. Okay, and we can see the fill volume and the dig volume. And again, this is a list connected to the 3D model. Okay, so if we, for example, select the terrain and we want to shrink this area because it's too large, for example, we can select the control points of this area, move it a little bit to that direction. Okay, so we get a less area of cotton fill. These values are updated. Okay. Well, another thing that we can do on this terrain is to add a path. Okay, so in this case, let's see if I find path axis. I think that's the layer. I've got this curve.
think that feature is quite useful in Iceland nature.
Yeah, absolutely. So we can find here a curve that I previously created. Okay, just with a regular curve here, which is now flat. Okay, so we can add a path on this terrain based on this curve, but now we'll get the path will be, buried into the 0 elevation. So something that we can do first is to project that curve on the existing terrain, and we can do this by telling that curve to be projected on the terrain to be adjusted to terrain. Okay. So now, once this is in the right position, actually we can adjust this to the right place. Okay, we can maybe move it a little bit up if you like. We can run the add path command. So we go to terrain, add path. We select the terrain. We define the width, let's say 3 meters, and again some slope. In this case, I'm going to say 20 centimeters. And finally, I select a curve. Okay, so we can see here that the path has been added. And well, in this case, it went a little bit up. But again, we can select now the terrain. We select this point that corresponds to the control points of the original curve. Okay, and then we can just move it up or down so the path will be adapted to the new position of the terrain. Okay, and now if we check the list, the terrain list, we can also see the the operation of this path. Okay, which is as it follows here.
Mm-hmm.
Okay, let's move on. Maybe it's worth it to show some of the hardscape tools. So we have here the wall object. We have already a few walls. For example, this one.
Is a short, is an edge. Mm-hmm.
Yeah, that's a wall object that has been created previously. But basically, wall objects are parametric objects defined by a thickness and a height. So we can change the height of this object and get a higher value. Yeah, there we go. Or we can insert a row of elements. For example, we go to the row command. We can select a block from the model, or we can browse it from any file that you have in your PC. Or also, RhinoLands includes a library of objects from either people or stones, playground equipment, okay, lighting. So there are a few objects that are included. You know that Rhino can handle a large amount of file formats. So probably if you download any 3D model from the web, RhinoLands will be able to open it. So you can actually use this command to on any of the blocks that you can import from the web. And maybe we can select any of these street lights, okay, and basically here define the row parameters. Also the orientation, if it's tangent, perpendicular to axis, so on. Okay, and we can define total number of units or the separation of them, and also distance to the axis. So I'm going to select the same axis that I used for the path. So I'm going to say that I want 2 meters, from each side of the from one side of the axis, and click OK. Select that curve, and we'll get the row of street lights in here. Just notice again that they have been automatically, you know, projected on top of the terrain. Okay. And yeah, if we select them, we can change the number of them and, you know, do anything you like.
Before moving forward, maybe we can answer this question because Gunnar, if I'm not pronouncing well, but Gunnar is asking that what about earthwork underneath zones? For example, gravel underneath asphalt or similar things. I guess well, they are asking about the volume of material for construction, right? Yeah, if that is the question, well, you can obtain the area by zonify command. So by zonify, you indicate that in this pass, for example, how much is the area of this pass. But for calculating the volume of asphalt or something like that, by having the area, you should do your own calculation manually.
Yeah, and actually, if you want to have maybe all the thicknesses, and you want to show the modeling section with all the thicknesses and the material and the thicknesses, you can use this section tool. So we can draw a kind of clipping plane, okay, and now from the let's see this clipping plane where it shows up. Oh, here it is. So it's a bit farther away.
In the meantime, if you have any other questions, please feel free to write them in chat box. Since we have a few minutes, but I'm sure that you will have more questions. So just don't be shy. Just write down your questions.
So basically, we need to place, of course, the clipping plane, you know, that is intersecting with the model, and now we can just activate the view where we want to see it, and we will be able to see the modeling section. And of course, in this case, we don't have the terrain with a base. Okay, we can add the base as we have seen before. We are pending, you know, to add some features to also cap this terrain, so we get a solid area on that object. But yeah, the idea is that if you want to see thicknesses of objects, you just create them using 3D modeling tools, because the zone command, the zone object, actually they are flat surfaces. So this is gonna give you only, you know, a surface with a line. If you want to have something underneath it, such as some thickness of layers, object layers, you may want to work with terrains, with surfaces, okay, or volumes that they have their thicknesses or their geometry, okay, and they will be clipped by the section.
Okay, so we have a few minutes. We may roll it up just to be
okay. Yeah, I mean, maybe we can see some of the just to finish with the vegetation. Maybe it's worth it to insert here a forest very quickly. So I'm gonna run the forest command, select some of these species, okay, define the size, the number of units of the forest, okay, and now we can just draw it as if we were drawing, for example, a polyline. And if you have, for example, the here we have all the OSNAPs. I want to disable it. If you have, for example, a curve previously created, okay, you can just select the curve instead, and we can see here all the plants. Okay, if they are too big, we can just come here and go to plant, change the size of these plants, or we can combine. We select this forest. We can combine different species. So we tell to have here to have two elements, and then by picking one group or another, we'll be able to change the species. Okay.
Well.
All right. So okay, maybe we can finish by creating some short animation of this scene.
Great.
By the way, there is a nice way to interact through the model. I'm gonna hide this this clipping plane. And if we go to the visualization commands, we can select this wall mode. This will just put you on the ground, will detect also all the paths and the terrain, okay? And just with the mouse cursor, we can just navigate through the project, okay? And with the wheel, we can change the speed, okay? And with the pointer, we can, well, interact
this
into the project.
helps to gain a feeling of how would be the reality, actually.
Okay. And another thing that we can do is create a short animation. And I've got here a curve in a hidden layer, which will be used for a camera path. Okay. And we can move to the animation panel, where we can define some settings, for example, the frames per second or the total duration of that animation. Here from the camera, we can have it as a fixed point or a curve. So we can click this button to define this curve as the camera path. Okay. I'll select it again, just in case. And well, you can either choose if the animation will be recorded using the Rhino display or your current renderer. RhinoLands supports V-Ray, Corona, supports any render engine that works on Rhino. Okay, so it's also supported by RhinoLands. We can connect this with Enscape, Twinmotion, Lumion, as we have seen before. But okay, if you just want to see a preview, we just need to click here on the play button, and you will see how this animation looks like very, very quickly. And based on that, we can just do any modifications and shut the final video.
But again, this is just the Rhino display. When you shot a render, you will get a very, very better results, actually more realistic.
Yeah, obviously.
And of course, it takes time, so we are not going to do that in the live demo, but yeah, that's the idea. Well, thank you, Francis. I must thank you all members of the associations and the committee of the Association of Landscape Architects in Iceland, and specifically Frida, who had to leave the session before. But yeah, and thank you everybody for joining this session. You will find more information on our website, landsdesign.com. And if you have any questions, just feel free to contact us. We are going to send you the recording of this session, so you can see that later or share it with your colleagues. The idea of this session actually was just to show you the capacity and the possibility of this technology that provides to us as landscape architects. And well, just feel free to try the free trial. Have a nice afternoon.
Thank you very much.
Thank
you
you.
Can reach us from the website support. You can find our email, and we'll be glad to help you with any request or suggestion. Okay.
Okay. Thank you.
Thank you.
Bye-bye.
Bye-bye.